Hello, my name is Krishna Aditya and I'll be presenting EyeAI, Detect Leading Cause of Blindness with AI. A whopping 12 million people are blind just in India. Diabetic retinopathy and glaucoma are the leading causes of blindness all around the globe. In countries like India, there's a drastic shortage of more than 1 lakh eye doctors, and just 6 million of 72 million diabetics are screened for eye diseases. Diabetic retinopathy is a diabetes complication caused by damage to blood vessels of the light sensitive tissues of the back of the eye, called the retina. With 285 million people with diabetes, one third of them have sign of DR. Glaucoma. Glaucoma is caused due to an increase of eye pressure and is a disease which is also hereditary. It is estimated that it will affect 79 million people around the world by the year 2020. A fundus image is crucial for the diagnosis of diabetic retinopathy and glaucoma. It provides a 2D projection of the retina. It gives the structural information of the optic disc and also the information regarding the retinal structures such as the cup, rim, blood vessels, etc. An ophthalmologist uses the fundus image to screen diabetic retinopathy. It shows various signs as shown in figure 1, insinuating the likelihood of diabetic retinopathy. For glaucoma, the region of interest is the optic disc. As shown in the image towards the right, the white boundary is the optic disc and the black boundary is the cup. Glaucoma manifests primarily as a structural deformation in optic disc. The important metric used in the diagnosis of glaucoma is cup to disc ratio, which is the ratio of the diameter of the cup to the diameter of the disc. So it will be a key to segment the cup and the disc and calculate the cup to disc ratio to diagnose glaucoma. I believe AI enabled vision centers can be used to screen vision for millions of people who don't have access to healthcare. It can also aid doctors in giving more accurate diagnosis. Coming to the solution, so as I mentioned about how the fundus image provides information to predict diabetic retinopathy and glaucoma, I went for with a classification based model for diabetic retinopathy. So I used an efficient net V5 to predict the severeness of diabetic retinopathy, which is in 5 categories, namely normal, mild, moderate, severe, and prolific DR. For glaucoma, it's about the abnormal size of the disc and the cup, which segment using an unit and compute the cup to disc ratio using my algorithm. I'll start with the demo. I use FastAI for classification and Pytorch for segmentation and Flask for the backend. So this is my web app where I'll select the image which I want to predict both the classification and the segmentation mask. So I select first from a normal fundus image. I plus predict and I get my prediction instantaneously which says no CDR, and I get mask on the right side browser. Let's take an example case of prolific DR. I choose an image from that test cases. I predict it. My model accurately predicts that it's a prolific DR and it also computes the cup to disc ratio. In the right, it also plots the masked image. Taking an example from the glaucoma images, we can see that the cup to disc ratio is very high and the optic disc is very big. On the other hand, in a normal glaucoma image, the optic cup to disc ratio is rather small compared to the one with glaucoma. So this is how we can conclude that the patient might have glaucoma or not and can be sent to a doctor.